Hello everyone, this is Flora and this is my Unix lab experiment number 4. So today my topic is base conversion using shell script. So basically we have number types as binary number, decimal number, octal number, hexa number. So in this experiment I'll be converting a binary number to decimal, a decimal to binary, or octal to hexadecimal, a hexadecimal number to octal, and a decimal to hexadecimal number. So what are these numbers? So binary number is a number which can be expressed with the base 2. So what is base 2 implies is we either have 2 digits in the number. So typically the values are ones and 0. Similarly for decimal it's base 10. That is our normal numerical system, that is from 0 to 9. Then hexadecimal has 16, base is 16, that is 0 to 9 digits, and then A to F alphabets, and octal has 8 base, therefore we have numbers 0 to 7. Now in order to perform this experiment I'll be using a sample data, that is the decimal of 100 when converted to hexadecimal will be 64, octal is 144, and binary is as shown. So my first experiment is to convert a binary to decimal. So basically binary to decimal, um so if you see, I have read the data from the user. The user will be entering a binary number. Suppose for example, it's number 2, which is 10. So then these are initializations so that I don't get any garbage value. Then I've used a while loop, and until 1 and 0, that is 2, is not equal to 0, I'll be performing this experiment. This reminder will give me either 1 or 0, because there are only 2 digits in the binary number, and this is used to concatenate remainder into power, will give us the units, tens, hundreds, so on places. And this is we are dividing the number by 10 for each iteration, so that we can find the remainder of each. The single digits are found using REM, and for each time we are dividing by 10, and the final is a decimal number. So when we execute this, we execute a shell script using sh file name. So here I'm asked to enter a binary number. So I am giving the sample binary number, and my decimal number is 100. Now next experiment is to do binary to dec to binary conversion. So if I do dec to binary conversion, what I've done, I've read the details from the user, a decimal number. Suppose my decimal number is 2. So until the number 2 is not equal to 0, I would be finding the modulus of it, that is the remainder part of it, and I would be concatenating it with the earlier number. So whatever number we get would be concatenated. Now when we find binary number, we always concatenate the new numbers with the previous number ahead of it. So that is the number obtained and then the number which we already had, and every iteration I'm dividing it by 2, and the final result is a binary number. So if I execute this experiment, now for decimal number 100, I would be getting the binary number as 110010, which we already tested from binary to decimal. My next experiment is to convert decimal to hexadecimal. So decimal to hexa, I have in this experiment I have used an inbuilt printing statement of shell script, that is x. Now in case if I give d, it would print the decimal part of it. Since I've given x represent the hexadecimal value, so I don't have to divide it by 16, find a remainder and concatenate. Rather than that, I can directly convert a decimal number to hexadecimal number. So this x represents the hexadecimal number. For example, when I execute this code, so I have to enter a decimal number. Suppose it's 100, and my hexadecimal number is 64, which is what we got from a sample data. Next I have to do is hexa to octal. So from hexa to octal, I'm entering the hexadecimal number from the user. Now you see there is an inbuilt class called obase and ibase. So obase is the output base. So if suppose I want my output base to be 2, in all the experiments that I did ahead of it, binary to decimal, decimal to binary, everything can be done with this same type, that is output base could be given as 2 or 10 or 16. Similarly for this experiment, since I want the output to be an octal, I give 8, and my input is in the form of 16, that is hexadecimal, that's why I give 16. So this will directly convert it. Now if we try to have, let's have the hexadecimal number 64, so our octal number is 144. So my next experiment is to convert octal to hexa. So it is the similar like we had hexa to octal. Similarly, my output base now, rather than 8, it would be 16, and my input base would be 8. So if I execute this one, that is input as 144, my hexadecimal number is 64. So this is all for experiment number 4, base conversion. Thank you.